All right, so this is part 3 of 3.2. What we're going to be looking at right now is going from a graph into an equation. And I'm just going to start off by saying this. So there are going to be multiple answers for every graph, multiple valid answers for every graph. Okay, so first off, here's what we need to do. We need to take a look at this and we need to make a decision for ourselves of whether we're going to be writing this equation in terms of sine or in terms of cosine. And then we need to identify a cycle of either sine or cosine for us to use in order to write the equation. So I'm going to go ahead and do this in both ways real quick. I'm going to first choose sine. I'm going to identify a cycle of sine. So remember, our sine graph looks like this. Starts at equilibrium, goes up, down like this. So I'm looking for a section of my graph that looks like this. Let's go ahead and identify one. There's actually a couple here that you could use. So I could use one right here. Hopefully you can sort of see that right there, how we can fit it in there. It goes up, down, back up. That's one cycle. I could go ahead and slide this over here. See it right here. Here's a cycle of sine. I could use this one. And here's a cycle here of sine as well. All of these functions, all of these periods will, when we write the equation, they would make the same graph. In fact, the only thing that's changing about them is their sort of horizontal positioning. So the only thing that's really going to be changing about their equation is that phase shift. How far are we shifting it left or right to sort of start looking at the beginning of our period, right? In this case, our period is starting at -2. So that would be shifting over to the left 2. Here, our period is starting at, I guess that's -6. So we'd be shifting over 6 to the left. Here, we're looking at a period where we actually shifted to the right 2 to start it. Doesn't matter which one of these you use. In general, some guidelines, people tend to use the first period after 0 to the right of 0. That's like a common thing to do. Something you can do, that's fine. Some people like to do the one that's like kind of closest to 0. This one's centered. It doesn't matter. They're all the same. We do need to be a little careful with some of them, though, because if we're using this to sort of model a real-world application problem and we write the equation based on this period, we will only be able to solve for things in this period. That's kind of a complicated thing that we'll get into the next section. Doesn't matter so much now, but it is a minor detail. Okay, now this is not the only way to write a sine curve. Remember, this is one sine curve. This is a positive sine curve, an unreflected sine curve. But we could also write it using a reflected sine curve. And I think you can see those in there as well. So let me go ahead and erase this thing. I could also choose a reflected sine curve. And I'm thinking there's one right here. Right there. Here's a reflected sine curve in this box. That's one of them. Let me move this over a little bit. Oh, here's another one. Another reflected sine curve, down and then up. And if this graph kept going, obviously there would be an infinite number of both of these for us to choose from. We got to make a choice. Doesn't matter. We got to make a choice. I'm going to do the positive sine curve. And I'm going to go ahead and select this interval over here to the right of the axis. So this is the cycle that I'm going to be looking at to write my equation. Again, just a decision I'm making. It's not wrong to choose one of the others. You're just going to have a slightly different equation in the end, but it will match this graph. Okay. What is our amplitude? So looking at this, our midline, we're going up 3 and down 3 from the x-axis. So that means that our amplitude is 3. Period. What is the period? How long does it take for us to complete this full cycle? What's this distance along the x-axis? In this case, since it's nice and whole numbers, we can just kind of count it. 1, 2, 3, 4. Our period is 4. If it wasn't so easy, we could take the end minus the beginning, the end minus the start. So 6 minus 2 to give us our period. Same thing at 4. Again, that's going to be more appropriate when it's harder to just count. In this case, it was hopefully easy to see that our period was 4. All right. The period does enable us to come up with one of the values that we actually use in our equation. So hopefully remember the relationship that the period equals 2 pi over b. So this I'm going to have to use in the equation to actually figure out what b would be for this equation. So we have 4 equals 2 pi over b. I'm going to go ahead and multiply both sides by b. So I get 4b equals 2 pi, and then divide both sides by 4. That gives me that b is equal to 2 pi over 4, which just simplifies to be pi over 2. By having our b value have a pi in it, that's what enables us to get these nice whole number increments along our axis and sort of whole number scaling for our period as well. But that's the value we'll be using in the equation. Remember, that's what actually goes in the equation is the b value. All right, moving forward from there, the next thing is the vertical shift. So for this graph, there was no vertical shift. We can see right here that the midline is the x-axis. So our vertical shift is 0. Oh, I skipped one. I'm sorry, I forgot the phase shift. That's actually a pretty important one. The phase shift is relative to 0. Which direction did we move for us to start the cycle that we're looking at? So in this case, we move to the right 2. So our c is going to be 2. We move to the right 2. And when we write it in the equation, remember it's like b times x minus c. It's going to be x minus 2 to show that shift to the right. So 2 to the right. Again, we decided to write this as a standard sine curve. We didn't reflect it or anything. So there is no reflection based on the period that we chose. And from there, we're going to think about how we can put all this together to write the equation. So again, let's look and see how we can kind of put this all together and write our equation. So we are writing a sine equation. I'm going to kind of write out what that form we had at the beginning of this section was. It was a sine b times x minus c plus d. For this equation, there's a couple things here that, we'll need to pay special attention to. So we have our amplitude, which is the a value is 3. Since it's not reflected, there won't be a negative here. And it'll be sine. Our b value we found was pi over 2. And then x minus c, we moved to the right 2, so it's going to be minus 2. And then there was no vertical shift. So we could write plus 0, but that's silly. We don't need to write that. Adding 0 to something doesn't do anything. So this would be the equation for this particular section of the sine curve. Again, it would keep repeating infinitely to the left and to the right. So technically it's the equation for the whole thing, but really it's based on examining this specific cycle of our sine curve here. All right, I'm going to erase some stuff and kind of pretend that I made a different decision. So hopefully this made sense, and we're going to kind of take a look at it and again, pretend we made a different decision here. So I'm going to erase a bunch of stuff. I'll try to leave that equation down there, just so we can kind of compare our answers. All right, now, I said in the beginning, I said sine curve, right? Sine curve. So let's pretend I didn't see it as a sine curve. Let's pretend I saw it as a cosine curve. So let's remember that a cosine curve looks a little different when we're looking at a cycle of cosine, right? Cosine has maximum, minimum, and then equilibrium points or midline points. So cosine curve, when we're looking for a cosine curve, we're looking for a cycle that looks something like this. So we're going to be going from max to max. Here's one, max to max. I could examine this cycle right here. And I could write an equation using cosine to describe this interval. What's different about it? What makes it different versus sine versus cosine? Not a lot. Amplitude is still the same, right? The distance from the midline to the peak didn't change because the graph's the same. The period is actually the same as well. It's not as obvious to that, but it is. we're going 1, 2, 3, 4. If it repeats every 4, it should repeat every 4 regardless of what section we look at, and it does. So our period is still 4. No need to change that, which means our b value is the same, pi over 2. So nothing to change there. Vertical shift is the same. We didn't shift this graph up or down at all. It's still oscillating around the x-axis. The thing that is going to change is right here is the phase shift, right? Because now, relative to our 0 value, instead of shifting to the right 2 to start there, we actually shifted to the left 1. So our c value is actually -1. We went to the left 1. And when we write that, when we plug it in, it's actually going to be, when we do it in here, it's going to be +1 because subtracting a negative is plus. And if we move to the left, we just need to remember that that's plus. All right, let's try to write this equation here. So we got y equals a cosine b x minus c plus d. All right, I'm going to go ahead and write this one out. So some similar parts. Our amplitude is 3. Cosine, our b value is still pi over 2. That didn't change because that was based on our period. Here's what changed is the shift. So we went to the right, or sorry, to the left one, so +1 there. Still no vertical shift. So this would be the equation, or one of the equations, using cosine. Again, there were a couple different cosine periods that we could identify in there. This was just the first one that jumped to my mind. All right, I'm going to pause for a second. All right, resuming here at our next graph. Again, I'm going to show 2 different equations that we can write for this one, a sine equation and a cosine equation. Totally up to you in terms of how you maybe want to identify it, because you have, like, I guess kind of 4 choices. You don't even, it's not even just a sine and a cosine. It's also, is it reflected or not reflected? So you could graph it as a regular cosine curve, a reflected cosine curve, a regular sine curve, or reflected sine curve. Kind of a lot of choices here. To me, I don't want to prescribe a particular way to this because you may see it differently. And I don't want to kind of take that away from the way that you view a particular graph. Some people just love to always start at 0 and just wherever it's starting at 0 and whatever that first period looks like, just do that. That way they don't have to worry about phase shifts, stuff like that. That kind of makes sense to me, but it also is like, I'd rather kind of do it a little differently. So in this case, if we are doing that, that's a reflected cosine curve. That's the way you'd want to write it. Some people say, I really understand how the sine curve works, so let me just find a nice sine period and kind of do it that way. So you might go from here to here and see that, yeah, that looks like a nice sine cycle. Doesn't matter which way you view it, they're all valid kind of options here. So let me go ahead and do this first. So I'm going to start by graphing it as a cosine. I could do it as that negative cosine that I saw here. That way we don't have to do a phase shift, but that actually seems kind of boring. I'm going to do a regular cosine curve, and I'm going to do it from here to here. So that's the cycle that I'm going to be looking at in order to graph this. Or sorry, to write the equation of this graph. A lot of these things are not going to be different, so I'll be able to keep a lot of these answers, but amplitude, again, we're going down to -10, up to 10. That's an amplitude of 10. And just kind of keeping that in mind, that means there's no vertical shift either because we're oscillating around 0. We're going up 10, down 10. So that's where our midline would be at 0. Period. What is the period? What is the length of this cycle? So here we're going from -0.5 pi, or half of pi, all the way over to 0.5 pi, half of pi. This one's not too hard. Hopefully you can see that this is an increment of 1 pi. Half plus half is 1 pi. If you weren't sure, you could take sort of the ending point minus the beginning point. So 0.5 pi minus negative 0.5 pi, which subtracting a negative ends up adding, and then we get our period, right? However you come up with that, a lot of these, if the graph is good enough, you should just be able to sort of count it out and see what your period is. Anyway, that is our period. It is pi. Next thing is about a phase shift. And so because of where I chose this, there is a shift. We're not starting at 0 on the y-axis. We are shifting over here. We're shifting over from 0 to negative 0.5 pi, negative 0.5 pi. So that's our c value. Remember, in the equation, it's x minus c. So when I write this, it'll really be x plus 0.5 pi. Or pi over 2, however you want to do that. Again, because I'm subtracting a negative value for that shift to the left, it shows up as a plus. Those horizontal shifts always work that way. They're a bit counterintuitive. And the last thing, is it reflected? Well, based on the cycle that we looked at, this is not a reflected curve. This is just a regular cosine curve. All right, so let's write out our equation. So I'm going to write out kind of the standard form that we were talking about before, the graphing form. One thing I did leave out is I did not use my period to solve for b. So if my period is pi and I'm supposed to do 2 pi divided by b, hopefully it's pretty easy to see that I would just need to cancel these out. So b needs to be a 2 in order to make this work. If this was more complicated, I would actually solve it, but this one's a pretty easy one that we've seen before. B is equal to 2. All right, what is the overall equation based on that cycle? It is y equals 10 cosine of 2 times x plus 0.5 pi plus d. No d, no vertical shift here, so I can just leave that off. And there would be this particular equation for this graph, again, that examines this cycle right here. Just for a quick comparison's sake, let's say that we were looking at a different positive cosine cycle. We could look right here. Again, going from this peak here to this peak here. Almost everything is the same. The only difference is our c value. Instead of going to the left, we're going to the right. And we're still going by half of pi. So our c is 0.5 pi. And in this case, that means that we would be doing x minus 0.5 pi. Kind of weird, right? They're like almost the same. It has to do with this sort of interplay of these points are exactly 1 period apart. And so negative 0.5 pi and 0.5 pi are exactly 1 period, in this case, apart. So you can always find a new equation just by simply adding or taking away a full period from that phase shift, by shifting a full period the other direction, or the same direction again, you can find a new equation. So I could write this one again just based on having a new phase shift, changing that from a plus to a minus, essentially. That particular change is not always this case. It's not always just changes from a plus to a minus. That happens to work in this case. Okay, let's do this one more way. A lot of this is not going to change. I'm going to look at it as a sine curve, though. Let's look at it as a sine curve. So again, I have options. I could do it as a regular sine curve or a reflected sine curve. Doesn't matter. Just for interest's sake, let's just do it as a reflected sine curve. Why not? So we'll start here and we'll end here, and we'll look at this particular cycle in between those values. So from here to here. And hopefully you can see that's a reflected sine curve. Starts at the midline, goes down, goes back up. Midline in the middle. That is a reflected sine curve. So for this one, we're going to have a yes, there is a reflection. Other than that, not a lot changes. Still has the same amplitude, still has the same period and b value. It's a phase shift that needs to be looked at, because now we're moving to the right 0.7 pi. So c is equal to 0.75 pi, or 3/4 pi. So when I write this, it's going to be x minus c, which is 0.75 pi. So that's going to be my phase shift for this particular sine equation. Still no vertical shift, same as the last one. We didn't like move the graph up or down just by choosing a different period. It is reflected though, because the period we're looking at is a reflected period. So let's go ahead and write this as a sine equation. So I'm just going to pretend this is sine and kind of use this as my outline. It is y equals 10 sine 2x minus 0.75 pi. No vertical shift, so plus 0, plus nothing. So that would be the equation based on this particular cycle that I'm looking at over here. That's one of many that I could examine, right? I could have done this by looking at a slightly different cycle here and done it as a positive sine curve, a non-reflected sine curve. But I chose this one here, so I left out an important feature. As I was saying that, I remembered this is reflected, so there should be a negative there to make that accurate. Okay, yeah, negative. All right, let's go ahead and move on. Look at another. All right, so let's go ahead and write this equation in two different ways. We have some nice scaling here. It does look like there is a vertical shift this time, which is a little bit different. So there's no set order that I need to kind of answer these problems in. I'm just going to try to identify some different things. So here's our upper bound and our lower bound, and exactly in the middle should be our midline. So what's exactly in the middle between negative 4 and 2? And so hopefully we kind of identify it right there. It's negative 1. So that gives me a vertical shift of negative 1. Again, that's kind of a weird one to maybe choose right away, but I think it's an easy one to find. That means that our amplitude here is going to be 3 units. We're going 3 up and 3 down from that midline. So our amplitude is 3, or absolute value of A is 3. Now, this is where once we decided those things, now to decide if it's sine or cosine or what are we going to do, we're going to do it 2 different ways. So we'll do one as a sine curve and one as a cosine curve. So let's do the sine curve first. So sine curves should start at the midline. So you can pick any of these places where it looks like it's starting at the midline. And I'm just going to choose, again, I've said this before, but kind of a standard place is the first one either at 0 or the first one after 0. That's just kind of a standard thing to do. So I can go here as my starting place, goes up and then down, and then, okay, back on the midline. All right, so looking at this right now, this looks, I look limited because my scaling doesn't tell me some of these numbers here. I'm actually having a hard time, figuring out what value this would be. I could make some assumptions. I could assume that it's right in between 0 and pi over 2. So I could assume that this was pi over 4. And I could assume that this is right in between these values again and kind of figure that out. But that's kind of making some assumptions. So perhaps I don't want to do this, what I'm doing right now. Let's step back for a second and see if there's maybe a better way to approach this. I think the better way to approach this is to look instead at, I'm going to undo what I just did. So let's, instead of looking at this as a cosine curve, or as a sine curve, let's look at it as a cosine curve, because I think those points are just going to be a little better for us. So let's do that. Let's look at it as a cosine curve. So cosine, kind of by standard, goes from maximum to maximum. So we could look at any of these cycles here. Doesn't really matter which one we want to do. They would all be valid. Those would be kind of our standard non-reflected ones. If we wanted to look at some reflected equations, we could go from bottom to bottom, totally up to you or whoever's kind of writing it. I'm going to pick the first one after 0. This is just the one I'm going to look at. So here is the cycle that I am examining right there. Starts at peak, midline, minimum, midline, peak. From there, we should be able to kind of take everything and write our equation. So our maximum value here is at pi over 2, and our other maximum is at 3 pi over 2. So if I want to find out my period, I can take the ending point minus the beginning point. which is 2 pi over 2 or pi. So this case I actually had a period of pi again. So period is pi. Remember, that means that b equals 2. That's a pretty standard thing. I mean, keeping b to be a small, reasonable number is going to be pretty common. Great. From here, we need to figure out the phase shift. So how far do we move over from 0? We moved over to the right, pi over 2. Instead of starting at 0, we move to the right, pi over 2. So that means that our c value is going to be pi over 2. And when we write that equation, it'll be x minus pi over 2.
Daddy, what are you doing?
Recording a video. All right, so I think we have all of our things figured out here. Let me just kind of run through them because I did them in a strange order. So I found my amplitude, A, found my B based on the period, found my C, the phase shift, and I already did D, which was our vertical shift, our midline. So we should have everything. We are writing a cosine curve equation. So kind of standard form here where we kind of fill everything out from there. Let's go ahead and fill out the numbers. So this was not reflected, so A is going to be positive. So we have a 3 cosine. Our B value was 2 to give us that period of pi. It's x minus pi over 2 to give us that shift to the right of pi over 2. And then D will be minus 1 because we shifted down 1. So that would be kind of my first equation for this one. And I'm going to go ahead and go back to thinking about this as a sine curve. And I think I am going to make some assumptions here. So let's take a look at the sine curve that I was examining before, which was something like this section here. So I am going to assume that this is actually exactly in the middle, so that this is a shift to the right of pi over 4. As far as things that change, that's one of the only things that does change here. Our vertical shift stays the same, our amplitude stays the same, our B value stays the same because the period is still equal. But right here, this is where we changed it. Instead of moving to the right pi, we moved to the right pi over 4. Again, that's making a little bit of an assumption based on what this particular x coordinate is here, but I think it's safe to do in this case. Yeah, everything else is the same. So let's just go ahead and write that equation. And this is also not reflected because it's a standard sine curve. So y equals 3 sine 2 times x minus pi over 4 minus 1. So that would be our second way to write that equation. Pink is a cosine, orange is a sine. And we could kind of adjust this around. We could examine even another sine curve if we wanted to, or a reflected sine curve, again, if we wanted to do it there. This is just kind of one of the options for us. All right, I'm going to clear this. Let's go ahead and do this last example, just writing an equation based on a description. So just some words here for us to use to kind of figure out what the different values are. I'm gonna kind of draw a graph, just might be necessary, might not be. Depends on how you feel about it. All right, so a period of 3 pi. So period of 3 pi, that would help us actually figure out the B value. So 3 pi equals 2 pi over B. So in this case here, multiply both sides by B. So 3 pi B equals 2 pi, and then divide both sides by 3 pi. That means that B is just going to be 2/3. So B is 2/3. That's a useful thing for us as far as part of our equation. The next thing we have here is the maximum value of 8. So our height is going to be 8. Our minimum here would be -2. That's minimum. Equilibrium is going to be in the middle of that. So if I kind of average those together, it would actually be at 3, would be our midline. So that means that our D value is going to be 3 based on where the midline is. And our amplitude here is going to be 5 because that's the distance from the midline to both extremes, to the maximum and to the minimum. All right, so we've got our midline, we've got our amplitude, which is 5. And the only thing that we're missing here is a phase shift. And so that has to do with where our cycle is beginning. So let's say in this case, our cycle is beginning at x equals -3. That means we're shifting to the left 3 pi over 4, which means that in our equation, we're going to have x plus 3 pi over 4. Remember, because it's really x minus c, and this right here is our c value. So when we do that calculation, that's what we get. The only thing that this is really missing here is whether we're dealing with a sine curve or a cosine curve. I'm going to go ahead and write this equation as though it's a sine equation. So let me go ahead and write that. It's y equals 5 sine, b value is 2/3, x plus 3 pi over 4 plus 3. There we go. There's no information about whether it's a sine curve or cosine curve. I probably should have thought about that when I wrote this problem, but there it is. And yeah, see you guys later. That's the end of part 3.